Hello. In this video, I will talk about monopolistic competition, and it will conclude Chapter 8 in the textbook. So far, we've talked about two extreme types of industries. And if we think about the whole spectrum of industries ranged by the number of firms that participate in them, on the one end of that spectrum, there's going to be a competitive industry with a large number of firms, and firms produce an identical product. And in this situation, firms have zero market power. They are forced to take the market price. And on top of that, there's free entry and exit. So there is as much competition as you can imagine, with firms just trying to outbid each other with a smaller price. And if there are any positive economic profits, more firms will be entering the industry. If the economic profits are negative, firms will start leaving. So that's one extreme case, a lot of competition. On the other pole, there is the monopoly, in which there is a single firm, no other competitors in the market, no close substitutes for the firm's output, and on top of that, there are barriers to entry. So really like zero competition, and the monopoly has all the market power in the world. And part of that market power is that a monopoly can set its own price. And so we looked at these two cases that are the exact opposite of each other on all the four key assumptions. And today we're going to look at an interesting blend of monopoly and competitive industry, and that blend is called monopolistic competition. So it takes some characteristics of a monopoly, it takes some characteristics of a competitive industry, and it operates in a very interesting way. So let's see. First of all, we're going to assume that in a monopolistically competitive market, there's going to be a large number of firms, just like in a competitive industry. Second, firms will produce differentiated products that will distinguish monopolistic competition from a competitive industry. Under perfect competition, firms produce identical products. In today's case, firms produce differentiated products. That means that each company's output is going to be slightly different from the output of its competitors. Next, firms will be able to set their own prices. So each of them will be facing a downward slope in demand, and they will be picking the price quantity combination on the demand schedule. And finally, there's going to be free entry and exit. And so, to sum up, the similarities between a competitive industry and a monopolistically competitive industry is in the large number of firms and free entry and exit. And recall that for a competitive industry, free entry and exit is the mechanism that drives the long run behavior, whereas the monopolistic competition is similar to monopoly in the sense that in both cases, firms are able to set their own prices. And so because firms are able to set their own prices, in the short runs, they will act like monopolies. That is, they will just try to maximize their profits facing a downward slope in demand curve. But in the long run, free entry and exit will result in zero profits. So a firm, a representative firm under monopolistic competition, acts like a monopoly in the short run, but acts under competitive conditions in the long run. And here's the example that I was thinking about. A good example of a competitive industry would be Uber or Lyft. When you need to get a ride, you don't really care who you get a ride from as long as they're well rated. So drivers offering rides through Uber or Lyft produce product that's identical. You don't care about the identity of the driver as long as you get the drive, as long as you get the ride. Think about monopolistic competition as Airbnb. No two rooms or apartments that you can rent through Airbnb are exactly identical. And so sometimes one place will have certain amenities that you need that the other place wouldn't, or one place will be more conveniently located than the other. So the products that are offered through Airbnb, that is, stay like apartments and rooms for lease, they're slightly different from each other. And so because of that difference, owners of their Airbnb properties have the ability to set their own prices rather than follow the market price that Uber or Lyft drivers are forced to follow. But in both cases, in the case of Uber or in the case of Airbnb, there's free entry and exit. If you want to be, well, probably it's not exactly free, but it's like the barriers to entry are very low. If you have your own car, you can register and be a driver. If you have an apartment, you can potentially register and rent it out whenever you're not residing in it. So in both situations, the free entry and exit results in zero profits, but in the short run, you are to charge the price when you're renting out an apartment, whereas you're a price taker when you're giving people rides, if you work for Uber or Lyft. So I guess this example should help you remember the difference between these two kinds of models. In one case, identical product and very tight competition, and in the other case, differentiated products, and so competition in the short run is not as tight. But in the long run, the pressure from other firms will still result in zero profits. Okay, next, let's look at the firm's decision in a monopolistically competitive market. And so the novelty here, and we're going to dive into some algebra, but if you follow me, I think it shouldn't be too difficult. The novelty here is we will make the demand for the firm's output be dependent on the number of firms in the industry. And so in this example, I will look at the restaurant industry, which to a certain degree is also a good example of a monopolistically competitive industry. Think about the various kinds of restaurants in Sioux Falls. They offer slightly different meals, but in the end, people just choose which restaurant to go to. So a Mexican restaurant and an Ethiopian restaurant and a fast food restaurant are competing with each other. So they're offering slightly differentiated products, but there is a large number of other competitors in their industry. And so to make this example fit into the monopolistically competitive industry model, we make demand be a negative function of the number of firms in the industry. So if there are more restaurants in the city, the demand for the output for the meals at your particular restaurant will decrease. That is the whole idea here. So we have the inverse demand, and we have a total cost function for the restaurant, and we need to decide which output level maximizes the restaurant's profits. And here, I'm going to solve this problem in general for an arbitrary number of firms. And then we will see how the zero profit condition in the long run will allow us to tell how many firms there will be in the long run. But so first thing first, to maximize a restaurant's profits, we need to set marginal revenue equal to marginal costs. And so we can obtain marginal revenue from the inverse demand by doubling the slope. So it's going to be 1,200 minus 140n minus 4q rather than 2q in the inverse demand. For the marginal cost, we can just take the derivative of the total cost. So take the variable part, differentiate with respect to q, you'll get 6q. Set marginal revenue and marginal cost equal to each other, and solve the equation for q. And you can see that you'll get q equal to 120 minus 14n. So your optimal output, again, will depend on the number of other restaurants in the industry, other firms in the industry. And now that we have the output, we can write down the profit function and simplify it to express the profit as the function of output. Let's do that. So first thing to do is to write down the profit the usual way as total revenue, that is price times quantity minus the total cost. And the next thing that I will do, which proves to be quite convenient in this example, is I will look at the variable part of the cost, the negative 3q squared, and I will factor out q from price minus the variable part of the cost. So I can express the profit as price minus 3q times q minus the fixed part of $12,500. And next step, let's replace the price with the inverse demand to express everything in terms of the quantity. And I'm just using the 1200 minus 140n minus 2q, plugging it in place of the price. And you can see that I have two like terms, 2q and 3q, so I'll add them up together. And another thing that I'd like you to notice is that what is left of the price, this 1200 minus 140n, looks like a multiple of quantity itself as well. And so I'm gonna pull out 10, and what's left is 120 minus 14n, which is exactly the quantity. So it turns out that in the optimal quantity, the price minus the average variable cost, so to speak, can be expressed solely in terms of the quantity. So it's going to be 10 times the quantity minus 5 times the quantity times quantity minus the fixed part of the cost. So it's going to be 10 minus 5, 5q times q, 5q squared minus $12,500. Okay, so that's what we have for the profit. 5q squared minus $12,500. Now, the next thing that we can do is to figure out how many firms there will be in the long run, because remember that in the long run, this expression has to equal 0. So we need to set 5q squared minus $12,500 equal to 0. This will simplify to q squared equal to 2,500, so q has to be equal to 50. So in the long run, to earn 0 profits, the firm will be producing 50 units of output. And if that is the case, then that 50 has to be optimal given the number of firms. So this will tell us that 120 minus 14 times the number of firms equals 50. So the equilibrium number of firms in the long run will solve this equation, and it will equal to 5. So what is going on here? One thing that I'm not mentioning in this slide is that if I replace quantity here with its function of the number of firms, so if I replace q with 120 minus 14n, I can express the profit as the function of the number of firms, and then for any number of firms I can calculate what the standing profit will be. And so it is sometimes convenient to express the profit in terms of quantity and sometimes in terms of the number of firms. Second thing that I want to point out, we know the long run equilibrium. We sort of know the answer in the end of the whole story, that there's going to be 5 firms. But let's talk a little bit more about the dynamic. How does it happen that the number of firms in this industry, in the restaurant industry in Sioux Falls in this example, will settle at 5? So let's look at a slightly different example. So we'll suppose for now that the number of firms is 3. And so when the number of firms is 3, the optimal output for a single firm is 78. And we can illustrate the problem that a restaurant in this industry is solving by drawing the graph that you should be familiar with from the Monopoly video. The blue line is the demand, the red line is the marginal revenue line, and it originates from the same point as the demand does, but it goes down with twice the slope, so it decreases faster. The yellow line is the linear marginal cost, and the only addition in this graph is that I'm adding the green line, the average cost. So for Monopoly, we didn't really care about the position of the average cost, so I just omitted it. But for a monopolistically competitive firm, average costs do matter much, so I'm going to be adding them to the graph. And so, as usual, the output is determined by the intersection of marginal revenue and marginal costs. That is where the red line meets the yellow line on the graph. That will give us the optimal output, and that's 78. And then the price will tell us, price at 78 will tell us the price that the firm can charge in this example. And you can see that when the number of firms is 3, price exceeds average cost. So the firm is making money for every unit that it sells, and so it's going to be making positive profits. And now we use the assumption that there is free exit and entry into the industry, and so because existing restaurants, existing firms are making positive profits, that's a signal for other firms to enter into this industry. And what happens when other firms enter, assuming that costs stay the same, the demand and thus the marginal revenue is going to decrease. So in this story, more firms will mean lower demand. In the perfectly competitive industry, more firms meant lower price, but here it's just going to be lower demand and the firm is still capable of setting its own price. It's just that it's going to be doing it at lower levels because it will have a smaller demand to deal with. Okay, so let's see. Let's see what's going on with the firm's profits in the current example before we switch to more firms in the industry. Currently, the positive profit is almost $18,000. Because the profit is positive, more firms will enter, demand will fall, and ultimately the demand will fall to the extent that the margin between the price and the average cost and the profit maximizing output will shrink to 0. And this is what's going to happen when the number of firms reaches 5. So graphically, and I'm going to go back so that you can see the difference. Average cost stay the same, but demand is going to shrink to the extent that at the profit maximizing level of output, average cost is just barely tangent to the demand. So at the optimal output, price and average cost equal to each other, and this is achieved by having demand be tangent to the average cost. But the good news is that in this scenario, you don't need to calculate any slopes. This is automatically achieved for the intersection of marginal revenue and marginal costs. And the interesting point here is that in the long run, in a perfectly competitive industry, well, output is 50, profit is 0, but price still exceeds marginal cost. The firm is able to charge 400 for the output, for the last unit of output that it produces at 300, and so because price is above marginal cost, the efficiency condition is violated, and there's going to be some deadwood loss associated with a monopolistically competitive industry, which is also going to be inefficient. It's going to be underproducing relative to the efficient price equals marginal cost condition. But you can also see that when the price equals marginal cost for a monopolistically competitive industry, the industry will be losing money because in that case, average cost will be above the price. The competition in this case forces price to equal to the average cost, but that takes place at an output that is lower than the competitive output. And this is, I guess, all I wanted to say about a monopolistically competitive industry. Thank you.